12, 7. Interesting. All right, I'll go to the emails I sent. Let's see if we can quickly find lesson 9. We spent so much time on lesson 7 that couldn't tell you where 7, 11, 10, getting closer. 10. Okay. One more. Come on, one more here. 5, huh? Well, I think I'm gonna do is just grab from the submission here. I don't seem to be able to find it. I will just start with a new Word document here. All right, so we'll share this. All right, let me make it a little wider here. Okay, so the teacher here says that on number 4, you have capitalization error. Let's take a look here. Aunt Jessica is the sweetest, most, sorry. I had a really bad day. My car broke down and a pop quiz in math. So I guess, and I forgot about the pop quiz. Okay, do you see anything that could be a problem here?
Um,
Something that should not be capitalized that is capitalized?
Math.
Yeah, I guess math is not a proper noun. All right, check. All right, number 9, you need punctuation after life. I want 3 things in life. So this is a semicolon, chocolate, comma, comfy chair, comma, and a good book. So a semicolon precedes the list with the commas. Number 13, you have a capitalization error. Let's go take a look. Oh boy. So this did not. Let's see if we can clean this up. All right. All right. So it says a capitalization error in number 13. Yeah. So something is capitalized that shouldn't be.
Capitalized as shouldn't be.
Well, that's the way I read it. It says you have a capitalization error. Maybe they mean that you should capitalize something.
The Middle Ages. Because I mean, yeah.
Okay.
So I'm right.
All right. Good job. And that says you do not need a comma before because.
We need a comma somewhere.
It says you don't need that one. All right. So I'm going to save this as lesson 7,
I mean less than 10. I mean 9.
lesson 10, 9.
Whatever.
Yeah. Yeah. The 7 is just what we've been doing for, a month. Is this lesson 10 just to be 11? 11 would be good.
No, wait,
Okay.
hold on. Wait, this is 9.
Oh, 9. Yeah. Yeah.
Yeah.
Okay. Oh boy. All right. So there it is. We got that one knocked out. Hopefully you'll get a grade on that, and then you can sort of pursue the next one. So let's go and look at, I think we left off on physical science the other day. Okay. So that's been done. Let's take a look at physical science. All right. So this is part of my responsibility. Where do you stand on this lab here on lesson 11? What do you need to be able to get this lab done?
Um, I think we already answered the questions, right? We answered those questions, I think, already.
It's waiting for you. Like you've got to go, you've got to get the cabbage, you've got to go through the steps here.
Yeah,
So
don't worry.
when do you plan to do that?
literally like today after I finished with you because we got all the materials finally.
Excellent. Okay. Uh, that's good news. So keep that going and you know, we'll just keep moving on here with our current lesson. So we left off on force and we're going to talk about inertia today. So you might need a calculator for other problems, maybe. I don't know. Not for these. So let me get that document open and we'll start working on that.
Okay.
All right. So we left off, yeah. All right. So let's take a look at these. All right. So it says which has more inertia, a passenger car traveling down the road or a freight train moving at the same speed. So the distinction here is being made between the mass of a car versus the mass of a train. And if you want to be very uh negative, you could think about what would be the impact of a collision, a car versus a train hitting something, which would be worse.
Uh, wait, what? Which one would be more worse?
Which one would be worse? A car, if you want to be negative, like that's probably the only way to think about these is a lot of physics problems are very negative. Like a car, I mean, you can be really negative here, like a car hitting a school bus or a train hitting a school bus. Like which
A
would be
car.
worse? Excuse me?
Well, I mean, a car is this. I mean, a train is the worst option because trains can't stop their motion.
Okay, but we're talking about the mass. So which has more mass?
A
A car
train.
or a train? Yeah. So we're looking for an answer here that says that the mass of the train is greater than the mass of the car, and so it has more inertia. So can you give me a sentence that relays that information, please?
Yeah, sure.
Is it clear what I'm asking you to do, Ivana?
Yeah,
Okay,
just trying to figure out how to write this. Like the train had more mass than the car, making it. I don't know.
exactly. Yes,
That's
exactly.
just
Make it, which means it has more inertia. And you could add in like, it'd be worse to be hit by a train than a car.
yeah. I'm not writing that.
Okay. I mean, maybe we should. What we're. I mean, okay. You're a figure skater. You're small, petite. I'm assuming. Um,
Yeah, kind
you
of.
know, right. And there's
I'm
probably
like,
much larger people on the ice, and it'd be like, what would be the difference between you hitting another skater versus them hitting another skater?
um, well, I don't know because I've never hit another skater. Uh,
Okay, that's good.
it's funny because when you describe me as that, I'm somehow 5'6", and it's funny because according to my mom, taller people have bigger feet, yet my feet are a size 6.5, 7-ish.
It's
I have
okay. It just means
small
you have
feet.
lots of shoe options.
I do. I could likely fit in a kid size if I tried. That's a possibility. But anyway, I've seen two skaters bump into each other, but it wasn't a thud. I've seen people fall on the ice really badly, and there's usually a thud, but I can give a good example. I fell a couple days ago actually, so I can get a perfect
Oh
example.
boy. All right.
It was a funny fall too, so um I was skating on the ice, and here's the thing: if you're not wide enough, you're it and which is that's a key thing. If you're not wide enough, your blades can get super close to each other and it'll make you fall.
Right.
Like they'll click against each other and then that causes you to go off balance and fall. That happened to me. I fell on my tricep. I'm fine now, surprisingly. And here's the thing, my coach saw me and someone else, I think. I got up, I dusted myself. I was fine. Like if anyone were to hear me, it would likely be a small thud. But the funny
And
thing is,
are you okay?
yeah, I'm fine. I I cried obviously, but I wasn't crying because it hurt. I was crying from the shock itself. I was like, okay, I'm still here.
Okay.
I was fine. I was just crying from the shock itself because I wasn't expecting it. Because I've fallen like that 2 times. This is the third. So, you know.
Okay. Well, let's get back here and talk a little bit more about inertia and force. It's related to what we've been talking about here. Um, it says, what do you think this means about the amount of force required to bring each to a stop? And so the simple answer is that the greater the inertia, the greater the force required to stop. And that's kind of what you're alluding to with the train. It would take more time, more force for the train to stop. Now you don't want to mention time. You just want to stick with this kind of language here. So
Yeah.
you would want to definitely make a comparison that the train would take more force than the car to stop. So could you give me a sentence or two um, about that?
Yeah. So like what I say like with greater inertia or like the train will need a greater force to stop. I don't know how to word it
Yes,
out.
exactly. Yep. And make sure you compare that to the car. Just say compared to the car, or you could even add in another sentence about the car needing less force to stop.
All right, here's what I wrote. I think that was right.
So the train has greater inertia. That's how we're gonna write this. The train has greater inertia and therefore requires greater force to stop. Good. Okay, let's look at the next question here. Which requires more effort to start rolling from rest, a golf ball or a bowling ball? So if you're not sure, we'll just
The
make it,
bowling ball.
yes, okay. So besides size, what's a big differentiator between a golf ball and a bowling ball?
A golf ball is lighter. A bowling ball is heavier
Exactly. So give me
because you
one
need a
sentence.
different amount of force to roll them.
Okay, we're gonna get to that, but start with mass. Start with mass. Just say that, and you can reuse the words in this question here. But say that a bowling ball requires more effort to start from rest compared to a golf ball because it has greater mass.
Man, thinking of a bowling ball now. Now I want to go bowling.
It can be fun, especially if you haven't
Yeah,
done it in a while.
yeah. I've been bowling since I was little. Um, it's a fun time, you know. Um, especially when I go with my dad because we're both competitive and it's fun. I also did type in the chat, by the way, like the mass and the with the bowling ball.
Let's see what you wrote here. All right, so let's start using words like greater rather than more. Greater, less. Um, well, I guess more is okay. Greater is kind of a more greater is a preferred word, I would say. Okay, so now which one will have a greater inertia?
The bowling ball.
Okay, so now you gotta give me a sentence that says that it'll have greater inertia because it has greater mass.
So I would write like the bowling ball has a greater mass or inertia.
It has a
Oh,
greater inertia because it has a greater mass.
all right, there.
Okay, very good. And then which one do you think will have a greater acceleration?
The bowling ball.
It's related to which one is the greater force. So you're gonna need another sentence that says the same thing. You could probably copy and paste.
All right, here's what I wrote.
Okay, and all right. So I don't know why I'm having so much trouble getting this to copy. There it is. All right, and So we you still have we'll just say acceleration and force to close this out. So give me one more sentence here that says which one would be harder to stop.
Hard to stop the bowling ball, right?
Yes.
Though in this situation, I would feel like it would be the tennis ball, but no, that would be the bowling ball.
Yeah.
'Cause once again, it's the bigger ball with the most
Yep.
inertia, the mass, the force. So, oh my God. Ugh. Like with a golf ball, you can use like one hand to stop it. With a bowling ball, sometimes you might need two, or wait until
I
it
mean, just
crashes
thinking
into a wall.
you're just thinking about like, yeah, like not how they might, going down a lane or you're just thinking about just kind of like side by side, same situation. So, um,
Right. I just finished writing.
all right. I like how you wrote that, and I'm just gonna add in the word acceleration.
Oops.
Now, one of the things I really like here is your writing, like it's more complete now. Um, really, really like that. Okay, so let's talk about a bicycle. Have you been on a bicycle in a while?
Yeah, I haven't been on a bicycle in a while, but yeah.
Okay, so it says a person is riding a bicycle down a flat road in a straight line. So just going down the street. What happens to the motion when the brakes are applied to the bicycle? What happens?
The wheels are gonna stop. Like they're gonna slow
Well, they
down.
don't they don't stop. They because if they did, you'd fly off the bike.
Will you slow down?
Yes. Now your wheels stop spinning as fast. That's what the brakes do. So yes, you slow down. The wheels spin slower until what? What happens at the end? You mentioned it already, but it doesn't happen. It doesn't happen immediately.
Um, Dang it, I forgot what I was gonna say, and I kind of
Well,
forgot
you,
what you
you well
said
you
a
just
little
well
bit.
you just told me. You said the wheels do what?
They slow down
Well, no, before that you said they come to a complete
to a complete stop.
yes until they stop moving. Okay, but that doesn't happen immediately because if they did, you'd fly over the handlebars. So give me
Yeah.
a sentence that describes that kind of, it's like a topic sentence. It's like overall, here's what's happening.
So I have to make a complete sentence about what's going on, right? Okay.
Yep. Driving down the road and then boom.
Here's what I wrote, by the way. I forgot to send it.
Okay. All right, so do you see any problems with your spelling of the word break? Oh, they misspelled it. They misspelled it.
Oh, oops.
I didn't even notice that. All
I
right, so I
didn't.
apologize. I thought you had did not see it. All right, very good.
It's okay.
Now,
Everyone does it.
so there's everyone makes mistakes. That's a reality. No one far from perfect. Okay, so one of you've heard of Isaac Newton.
Yeah.
Okay, so one of his laws says that for there to be motion, or for an object to go into motion, there has to be a net force on the object. Like you
Yeah.
don't instantaneously start ice skating. Your car doesn't instantaneously, start moving. There has to be a net force. Okay. But when you stop moving, the net force is now what value? If it's no longer moving, what's the net force on the object?
Um, it's not moving.
So, yeah. So what is the net force? It's a number. What is the net force if an object is not moving?
0.
Yes. Okay. So again, you don't have to reference Newton, but you can say that for an object to be in motion, there has to be a net force on the object. And so when it's not moving, the net force is now 0. So can you make a sentence that describes that, please?
Yeah, sure. I can start off the sentence by saying when the bike is moving, or like,
Yeah, you could say when the bike is moving, there's a net force. Um, you know,
I don't know what the net force of a bike moving would be. Hold on,
well,
I
you
should
just have
search
to
it
you
up.
just say that you just say that there is one. You don't have to know what it is. You just have to know that there is a net force on the object. Like when you're in an airplane, you don't need to know exactly how high you are. You're just
Doesn't a bike go up to like can't a bike like go up to 20 miles per hour? I don't know.
so guy that I play golf with, he rides bicycles pretty competitively. 30's pretty fast, 25's like what most people sort of tap out at. And they actually make electric bikes now that'll help propel you to that speed if you can't keep up with your legs.
Yeah, I used to have an electric bike. That was fun. I miss it. I
Yeah.
have a scar from that electric bike though. I fell in the dumbest way possible. I don't even want to talk about how I fell. Can I just say a net force of 20 miles per
No,
hour.
no, you just have to say a net force. Like think of it as a thing, a net force. It's like just think of this example, like um you just have to say that like it's in motion. That's like you don't need to know how fast, you're just saying there is a net force. That's it.
Gotcha.
You don't have to say what
Okay.
it is of. Good.
I think what I wrote in the chat is what you wanted me to do.
Yes,
All
that's
right.
exactly it. That is exactly it. Okay, very good. All right, when the bike is moving, there's a net force. The bike stops moving, the net force is zero. Very good. All right, now, uh, okay. Now, how about acceleration? The acceleration, um, so there's, and you know this because you're driving, there's actually a deceleration of the bike
Yeah.
until it stops. That's you pressing on the brakes when you're driving. And then the inertia slow also goes to zero. Um, so basically both go to zero. Both acceleration and inertia go to zero once the bike stops. So you want to say something about that here, that the bike is decelerating. That's what causes it to slow down until it stops, and the inertia also goes to zero because it's not in motion.
Okay. So wait, we're still writing for this one. Oh no, I don't know what to write.
Yeah, we're almost done. We just got to talk about the acceleration and the inertia, and then we're done with this question.
Oh, I forgot what to write. Oh no.
It's right
For the
here. I mean,
inertia.
I'm giving you like the cliff notes. You just gotta go in and put that into your own words.
Okay. Can I say like the bike's acceleration? I don't know. Declaration. I don't know how to word this first sentence. I don't know.
Well, the to slow down, it has to decelerate. That's what happens when you apply the brakes. It starts to decelerate.
All right. So can I start with saying the bike's deceleration causes it to slow down? I don't know. I'm gonna just
Yes,
do that.
that's exactly what it is.
Okay, there we go.
Right. So we'll go with that. All right, so move on to the next question here. It says friction is a net force that stops and or slows down many everyday objects. Describe one situation where friction acts upon it. Okay, so we already talked about that with the brakes, but let's think of something else. Anything that um, you can think of where there's friction? Maybe you've heard that in some
Yeah, I have.
situation. Okay, can you think of one for me?
Uh, ooh, no, I can't think of something when you ask me.
Okay, well, what's one thing we almost always talk about when we do writing that you participate in?
Typing on the computer. Oh, skating.
Skating. So is there friction between your skates and the ice? So let me ask it another way. If you just push yourself from the side of the rink, will you stop before you hit the other side?
No. I mean, yes, statistically speaking, because you're holding onto the wall, but
Well, I mean, that's pretty strong. I'm asking you just you gentle push from the side of the rink
oh, then
to,
no.
are you, okay. What do you think causes you to slow down? Because there's nothing acting upon you. There's not another person, there's not wind. What do you think causes it to slow down?
Oh, okay, that's a good question because I don't even know. Let me think this one. Hold on. Well, I can say for me that I can slow down by braking, but that's like putting pressure to on the ice to help you stop, so I don't think I can count that.
Right. So there's friction between your skates and the ice.
Right.
So give that, put one sentence together. That's your one situation. Give me a sentence that describes what we just said, that there's friction between the skates and the ice, and that causes you to slow down.
Oh no, I there's should I can I write the sentence there's friction between when I ice skate?
You're describing a situation. So like describe it. Say, when I go to the blank, this and I push myself from the side, I I I slow down and come to a complete stop because there's friction on the rink.
Uh, I think I wrote that right. Can you check on in the chat?
You're not describing what the friction is between. What is the friction between?
Oh, right. Forgot that. I forgot the key, most important thing.
Yes, let's add that in there.
Okay, there we go.
Very good. That looks a lot better. Okay. All right. So the next thing here that it's asking for, it says to talk about inertia, acceleration, friction, and net force in your description. So it's it's a lot like, you have to just, it's basically the same description that you gave here with the bike. Basically, you, we'll just go one by one here. Um, the inertia goes to zero. The acceleration, you decelerate, and then it goes to zero. The net force goes to zero. So can you give me a sentence that says those three things in there? It's
Yeah.
just like, it's just like what you did for the bicycle. It's just now you gotta say in your scenario.
Okay, there we go.
Okay, when I stop on the ice, I decelerate my. All right, that's good. Okay, I like it. All right, let's see what's next here in your lesson. Go back to your lesson. Okay. I forgot how long some of these questions are. Um, all right. So let's take a look. Let's see if we can answer one more. It says two cars have the same engine and wheels. Okay.
Okay.
It is determined that experimentally that both cars produce the same force over a 100-meter course. Car A can accelerate twice as fast as car B. Explain this result using Newton's second law. All right, so this is Newton's second law of force equals mass times acceleration, or more generally, you'll see this is F equals ma. M is mass, A is acceleration. So the acceleration, if we solve for acceleration, it is force divided by mass. Is that clear?
Yes.
Okay. So it says here that car A can accelerate twice as fast as car B. There are two possibilities here. Car A is either, okay, uh, half the mass, okay, or car A applies twice the force. So there's only two variables. So one or the other is affected, not both.
Mm-hmm.
Does that make sense?
Yeah.
Okay. So we're not going to be able to probably explain that here. We'll just leave that kind of there. Let's really quickly do this one here. So F equals ma, and acceleration is force divided by mass. The force is in newtons in this next problem. So it's 45 newtons. The mass is in kilograms. Could you grab a calculator and calculate that for us, please? 45 divided by 0.775.
That's 60.
That is 60. Okay. All right, so the units of acceleration are 60 meters per second squared. And then that will lead us into doing question 7 here. So I'm gonna go ahead and stop here for now. Now, unfortunately,